Welcome back again, guys. So this time I'm again going to do give a virtual contest, weekly contest. Okay. Yeah. So yeah, this is the one which I'll give, which is you weekly contest 456, and let's see how many I solve. Okay, so the first question is given a string, partition it into unique segments according to the following procedure. Start building a segment beginning at index 0. Okay, continue extending the current segment character by character. Okay, what does that even mean? Continue and extend the current segment character by character until the character segment has not been seen before. But once the segment is unique, add it to your list of segments, mark it as seen, and begin a new segment from the next index. Okay, what does that even mean? Let's see this one. So A, scene segment is this, current segment, okay, no, then this one, and again B. Okay, so yeah, I think this is almost going to be at worst case n square solution, but I don't want a n square solution. So I need to, maybe I can use hashing techniques, but yeah, like it's the first problem. I don't think hashing will be required. Okay, let me see how much is okay. As dot resist to the power 5. Okay, so alright, so let me try to do brute force at first, and maybe I'll use unordered sets. I don't know. What is the length of okay, so I think like I can use hashing to speed up the things, but I don't think I will be given a chance to do that. Yeah, the problem is only when this is the segments. Okay, let me try to think. Like first one will be 2 to the power 0, the second string will be 2 to the power 1, and then not 2, actually it will be 2 of them, and then 3, and then 4, right, and then 5. So something like this is going to happen: 1 plus 2 plus 3 plus 4, okay, from L or K maybe, and this will be equals to some s dot length of s, right? So at worst case it will be going k times k, like k square is equals to let's say s dot length is n. So this is what it's going to be. So what I can do is, if at worst case this is going to be the thing, and each k is of length, is of at max it's of length, I don't know what we can do. Okay, so there is my food. No. Okay, so my drink came. Okay, yeah. So this on an average, this thing is almost going to be, I think, k by 2. So it at worst case it will be, so while checking, I think it will almost take not more than k, right? So k is almost square root of n. Okay, k is almost square root of n, and at worst case this is going to be the thing which I'm thinking. And in order to check, I'm going to obviously use a set. So if in the set so in the set, how many elements are going to be there at each time, there is also going to be k. So it's and a k times log of k. K times log of k is going to be the checking, and we are going to do this for, so it's almost like k square log k, right? Which is k square is n log k, which is fine. So it's almost like n log n, so it's fine. Yeah, so I can literally use a set, so it's not a big deal. So yeah, let's do that. Okay, so wait, yeah, so let me use the set st of strings, right? And now I have int I equals to 0 while I is less than n, and also let's take a j equals to 0, so it should be this. If st dot find s dot sub str of j minus I comma I, sorry, I think I mistakenly write this. It will start from j and go from j minus I plus 1, and if this is the sub str is on the set, right? How to check if it's on the set or not? So if it's not equals to st dot end, right? If this is the case, then what I'll do, yeah, I'll just not do anything. But if he did not find, I'll insert. So let me also do this thing, string x, which will be this, which will check this. Hashing will reduce the time complexity by, I think it will be better, but yeah. This is good. Okay, so I equals to j plus 1, right? And j plus plus, or maybe I'll do this thing, I plus plus, right? But if then I just do j plus plus. Yeah, I think this is good. I just return the set. So also in the same time, I'll have this string answer. What I'll do, I'll tell you what I'll do. When I insert x, I also do this. So and then I just return answer. This should work fine. Yeah, it's working fine. Let's submit this. Yeah, let's move on to the next question. Longest prefix between adjacent strings after removals. Okay, so you are given an array of string of words, which is, yeah, so lot of strings today. For each I in the range 0 to words of length, words total length minus 1. So okay, perform the following steps. Remove the element at index I from words array. Okay, so whatever the element that I have in the index I, I'll remove that from the words array, and then compute the length of the longest common prefix among all adjacent pairs. Okay, longest common prefix. What is the constraint of this thing? Oh, damn. Anyways, so I need to compute the length of the longest common prefix among all the adjacent modified array. Like if I remove an element from index array, and then I'll compute the longest common prefix among all the adjacent pairs in the modified array. Okay, return the answer I. I is the longest common between adjacent pair after removing the element I if no adjacent pairs remain, or none share. The answer of I should be 0. Okay, alright. Well, I'm thinking of pre-computing the longest common prefix that we can have, right? The main problem is the time complexity, which is going to make it worse actually, because if I try to find out the longest common prefix, like we have this, if this is not there, then it will be 3 3 3, and then we'll have 0 0, something like that. Okay, but if I try to do find the longest common prefix for each of the each of the things here, it will most probably give me a TLE, because at the worst case it will almost be like 10 to the power 9 operations. So I cannot actually do find all of the how can I pre-compute this thing? Like, is there any way to pre-compute this, or no? Like, how can I like take the longest common prefix of adjacent strings? Okay, compute the compute the length of the longest common prefix among all the adjacent modifiers. Okay. Longest common prefix. longest common prefix that I have. So well, I'm thinking of using a try. Tries can solve this kind of problem easily, but I'm not really in a mood to implement tries right now, especially not for this question. I think we can do this question without the need of tries. Don't you think? Okay. Should I implement a try now, or what should I do? Like, I'll put jump, I'll put run there, and for each I'll try to compute the prefix. Wait, what are the constraints? Okay, shit. Okay. This is the important thing. The sum of word side or length is smaller than or equal to. I don't need to implement it. Try. Thank God. Shit, man. So yeah, I'll just. The maximum is from the left side and from the right side, or maybe just compute the adjacent. Okay, so let me create this thing. Adjacent. Okay, this will be of length what's that side, so this will be of also n comma where, and this will be almost n minus 1 because I'm going to start from I equals to 0. So for I equals to 0, I is less than n minus 1. Oh great, again there is no light. Anyways, so for I'll just compute the longest common prefix. So I'll try to sum is equals to 0, or maybe maximum pref max pref, right, is 0, and then I'll just take a loop. J equals to 0, j is less than words of I dot size j plus plus, and what I'll do, not this actually, minimum of words dot I plus 1 dot size comma whoever the minimum is, right? So let me do this. Let me copy this thing. Okay, I put paste this here, and then this will be the length. Right now, what I'll do, I'll try to check if words of I is equals to words of j, something like this, right? Then I'll be like, okay, max pref equals to j, right, j plus 1 actually, else just break, correct? So this will how I'll try to create the maximum, and then adjacent of I is just equals to max pref, right? This is how I'll create this thing. And now for for each word I. So I know the maximum. I just compute the how to put this. Yeah, for each of them I am also going to compute the maximum, correct, the suffmax and the prefmax. So we do that. Okay, this will be almost of length n. This is also n, or n plus 1 maybe, if okay. Now for anti I equals to 1, I is less than equals to n, I plus plus, what I'll do is that pref of I is equals to pref of I minus 1, and I know that we are computing the maximum, so maximum will be 0. So add, so this is almost going to be of n, right, adjacent of I, correct, I minus 1. Yeah, so this is the maximum of this guy. This will be what pref, and now similarly I'll just pre-compute the suff as well. So it will start from n minus 1 and go to 0, or maybe just 1. Suff of I equals to suff of I plus 1, comma, adjacent of yeah, I think this is correct. So whatever the I plus 1 I have suffix, and whatever the adjacent I have here at n minus 1, try to take this. Okay, so now it's fun. Now the only thing that I need to do is this thing. I need to return a vector, so let's do this. Vector answer n, and yeah, this thing. So obviously answer of 0 is going to be actually suff of not 0, not 1, it will be of 2, right, suff of 2. And if you look at words dot length, it starts with 1, but if it starts with a 1, so suff of 2 should be there, because 1 plus 1 is 2 actually. Okay, suff of 2 will not be there, so how are we even doing this? Shit. Okay, do it. Okay, shit. Okay, I'll do it here. Suff of I plus 1. Max of. Okay, so the first thing I'll do is what I'll do. Okay, so for first I'll do this. Okay, so I'll call a j, which is, because if it's I, suf of I plus 1 is actually going to give me from 0 to n minus 1, who is the maximum. What is the maximum? Right. So I'll have to do I plus 2, right? So from so this is what it's going to be. So I plus 2, right? If I'm at 0, then I'll ask to go to I plus 2, and if I'm at because that's going to be the suffix from there, and okay, alright, I think this will be it. And int k, let's say it is going to be from I plus 1 will give me the pref of I will give me from I plus 1 will give me from maximum from this to this. I will give me the maximum this to this. I need okay, yeah, k is just I. So first thing is going to be if j is less than or equals to n minus 1, correct? Then I'll also create a value maximum, which will be 0 initially. Maximum will be max of maximum, comma suf of j, right? And also suf pref, because it's going to go till n minus 1, and I don't think, yeah, for both of them n minus 1 is possible. So I'll try to, what is this, whatever, yeah, pref of I, comma, maybe I should just directly do this, right? Yeah, this is great. So like for example, when you reach n minus 1, the pref of n minus 1 is just going to give you what will it give you? It's n minus 1, right? So answer, which the answer actually contains 0 to n minus 1, right? N minus 2 actually. So when you reach n minus 1, when I reaches n minus 1, what happens at that time? Oh, why am I not able to think? So if pref of I, sorry, so answer actually contains everything. Sorry, answer, not answer. So pref of I actually contains everything from 0 to I minus 1. Correct. So let's call pref of 1, which means it's calling adjacent of 0. Pref of I, it's calling adjacent of, so pref of I minus 1. So pref of n minus 1 is calling adjacent of n minus 2. So if it's calling adjacent of n minus 2, it's actually taking the last value as well, but I don't want to take the last value, right? So only do this if I is less than n minus. Okay, yeah, one more thing is to actually be sure about it, is that pref is never actually going to go till n minus 1, even though it is quite going. So I need to explicitly write this. So if I is less than n minus 1, then do this. Else just give me a 0. Yeah, this is fine. J will be I plus 2, that's okay. And now in here also I am going to do a little tricks or something like that, because I is gone. If I is greater than 0 and I is less than n minus 1, okay, then I'm pretty sure that the I minus 1 and I plus 1 are merged. So I'm going to just copy paste this thing, right? Yeah, full brute force. Okay, so I'll copy paste this thing and I'll be like, okay, if this is the thing, the guy, and then break, and then when I have max of pref I, this answer is going to be on answer of I is equal to maximum comma max pref, right? It's as simple as that. Yeah, I just return answer. I think this should work. I don't know if it will be all right or not, but yeah, as you can see, surf here is going from n minus 1 to I, so suffix is probably fine, right? Surf of I means it is going to give from adjacent I minus 1 to n minus 2, I think, right? Okay, so when if j reaches the end, then for if it's n, then I pretty sure that maximum is just 0 there. If it is n minus 1, then again it's probably going to be a 0, because it really doesn't start like that. N minus 1, if I is n minus 1, right? If j is n minus 1, then okay, yeah, so there is some mistakes that I've made here, because if j is n, or what am I even doing? So I plus 2, which means that it's talking about not 1 but this guy. But this should work. Let's try to see. 033. Okay, this is really, I didn't think of this. Okay. Yeah, so there are a lot of mistakes then. Adjacent of 5 minus 1, adjacent of 5 minus 1. Okay. Zero to n minus 2, which is from 1, 2, so I is 0, so j will be 2. Should be 3 here. Why is it not 3? This is all right. The problem is with this one, pref of n plus 1. Pref of I is giving me result of I minus 1 to what is the maximum between 0 and adjacent of 0? And then suffix also, I think this is also correct because I is n minus 1 initially. So I think then the only wrong thing will be this thing over here. Okay, so here if I equals to n minus 1, it will be like n minus 2 adjacent of n minus 2, right? So I see everything being okay here. I don't know what is wrong. There are n minus 1, right? I think this is okay, but I think here is what is wrong. Here is y minus 1 and I plus 1, I minus 1, I plus 1, and this. Let me do it again. 0. Why the first one is 0? I don't understand. Okay, now this is something which is wrong again. Okay, I think I'm feeling very hot. I think I should turn on the air coolers. There is going to be a little sounds, and I'm sorry about that. Okay, I don't have the mental picture right now. I think that's what that is what is wrong with me right now. So J, I am in I, and I want to find I equals to 0, and I want to find out if I gets deleted, what is the maximum suffix that I can get, and that question will be given by adjacent of I plus 1, but adjacent of I plus 1 is just suff of I plus 2, right? Yeah, exactly, that's what I did here. Okay, and if I am at a particular I, how will I get the prefix of if I am here, how will I get the maximum prefix? So I will give me the adjacent of I is going to be this guy over here, that I can think of. Okay, I am imagining certain things. So adjacent of I is actually going to give me the maximum common prefix of I and I plus 1, correct? But the thing is, the prefix of I is going to give me the prefix from I minus 1, right? From 0 to I minus 1, adjacent of 0 to I minus 1, right? The prefix of I is going to give me 0 to I minus 1, but I don't need I minus 1, I need I. Yeah, so this is the thing that I'm doing mistake. Should be this, and I should be greater than 1, then only this. So pref of I minus 1 is the answer. Yeah, I think now it should work. 0 0 0. I hope please work. Okay, thank God. So too much time waste. You are given an integer array nums and an integer k, which I can clearly see. Your task is to partition nums into k non-empty subarrays. So my task is to partition nums into exactly k non-empty subarrays. For each subarray, compute bitwise XOR for all of its elements. Return the minimum possible value of maximum XOR. Okay, why am I getting a feeling of binary search? So like I need to divide it into k subarrays, right? That's the first thing. Oh, nums dot length is 250. Okay, now that is something crazy. I can do n cube, I guess, right? I can do n cube, but should I do n cube? That's the main question. Firstly, I think I should try to compute the prefix. So vector of ref which is just going to be n plus 1, okay, in the beginning. And now what I'll do is, for int I equals to 1, I is less than equals to 1 plus plus, the pref of I is going to be pref of I minus 1 XOR nums of I minus 1, right? Now this will contain all the, now I will be able to, you know, try to divide this into k subgroup, or maybe I should do dp, right? Should I do dp or should I do binary search? Like, it's giving me a feeling that it will be dp, but because the pattern is almost similar to binary search, I am really confused in these two, because like it's not like I'm just trying to match pattern, it's just that, like, it's very tempting, that's what I'm trying to say. So okay, let's try to think of and come up with an algorithm that will solve this question. So so now what I'll do, I'm obviously going to work with this prefix that I have got here, like from 0 to, so from 1 to n minus 1. I'll try to, you know, divide it into k subgroups. Okay, I need to divide it into k subarrays. And this k, I need to partition into k subarrays. Right. So let me define a state. So let's say I am at index I, and I am, like, from I to n, I am left with exactly j partitions. Okay, and I am trying to find out from I to full n, if I can do j partition, what is the maximum XOR that I can get. Oh, okay, I don't need to compute the maximum XOR that I can get. I just need to compute the minimum of them actually. Okay, k is around n. Yeah. I got it. I think I need to compute the minimum when I do exactly from I am at I, and from I equals to I to n, I am left with j partition. Like, if I do j partitions, I want to find the minimum XOR that I can get. So this will be like something like, let's say, for j from, I can partition at I to j is less than, you know, I'll have to partition to shit. From j equals to I to, like, I partition at I to, I'll partition at because I have j partitions which are left. So n minus, in if I partition at I, so I'm left with I plus 1 and j minus 1, right? So I plus 1 to n, so I'm left with I plus 1 to n, right? I plus 1 to n, I'm going to have at least j values, right? Then only I can partition it into j minus 1, correct? So I need to leave j values, so let's scale from I to n minus I minus j. So n minus j is going to give me the index where j elements are still left. Equal. So now j elements are left, but you can do like you can go j minus 1. So it's definitely this. Yeah. And now from here to here, when I partition it, I'll go with dp of I plus 1. So what is the minimum value of the maximum XOR that I can get here? Okay, j minus 1, or this is k, right? This is k plus 1, sorry. Yeah, k plus 1, definitely this will be. And I'll say that, yeah, I'll take the maximum possible value, maximum of this, comma, what do I have initially, like from k to I, right? So bref of k minus bref of I minus 1. This is what I need to do, and among these I'll take the minimum, min. Yeah, that's what I'll do. This is exactly what the dp should be, right? I think this is what it will be. So let's try to do it. So what will be the base case, guys? So base case is just going to be nothing else. If you are at n plus 1 and you are at 0, partition into it and it came here, and now you have 0 partition left, and then this is just equals to 0, right? That's the base case. That's literally the base case. Okay, const int n, which will be 253, okay, and dp of n of n, and I'll be like, okay, now for and I equals to n minus 1, right? I is less than equals to, sorry, less than equals to 1, I minus, and for a particular I am going to do this. So it's like for k equals to I, so one more thing, if not only this, if I if I am not able to partition it, okay, so let's say for example I reached the end, but I reach the end dp of n plus 1, but this is still sum of some j. Okay, then you need to return something which will be very bad. Those kinds of things you need to return. Now what is going to be very bad? Maybe I can just return -1, because I need to find the minimum possible value of the maximum XOR. So I'll have the minimum possible value, the maximum XOR, right here, and now this is also whoever is max, I'm just going to take that and take the minimum from among them. That's all right, that's very good, but yeah, I'll think about it for a while. Let me try to do this right for now. Equals to n minus j plus 1, right? One more thing for clarity is that I'm using a one base indexes, right? So here when I'm talking about n minus j plus 1 is actually going to give me something else that I don't need. This will be the correct thing, right? Because I am at n and I'm doing j minus 1, so I'm at that particular k where I'm doing n minus j minus n to j minus 1, right? So there are total of when I do j minus 1, what is j minus 1, then there are, what am I doing? When I'm subtracting j minus 1, what am I actually doing? From n, when I'm subtracting j minus 1, j minus 1 and I'm here. So the amount that I have is actually j minus 1 as well. Okay, I think I was doing the right thing. Yeah. Okay, what I'll do this int maximum, which will be int min, and then minimum, which will be int max. Okay, and this will be ref max of dp of k plus 1 j minus 1 comma ref of k minus ref of I minus 1. Okay, and the XOR values, sorry, whatever it's not minus, it's XOR, right? Now whatever the maximum is, minimum equals to min of minimum comma maximum of this is literally going to be the thing, right? Okay, now the important thing is what are still the base cases. That okay, so one more thing is that what I'm doing here is I always need the value of n which is greater, right? So I am coming from the last moment, so it's actually all right. So let me if I want to find the minimum possible value, let me initialize everything with int the max. So 90j equals to 1 to j is less than k, and j plus plus. Okay. Oh my god, this is interesting because I used this variable. So let me change it to capital here. Okay, yeah, so for this thing, what I'll do, I'll dp of n plus 1 of j is just equals to int max. Okay, now so if dp of k plus 1 is j minus 1 is int max, so I do continue because I don't want to take anything. Or maybe I should not do continue, right? I should let it be as it is. Maximum value is still going to be, and then in the end I just return dp of 0 1, try to 1 by common, and then I have k. Just verify this. Just try to see if I'm getting the right answer. J, so what is j here? It should be, there is no j. How many is j? Wait, what? What the heck is this? dp of I is I plus 1 is what I need. Now I think it should work. Yeah, and also like dp of I of j is one partition, and also when it has no partition, but for no partition I think I already have. Yeah, okay, for no partition I think I've not done it. Yeah, 0. For n equals to n plus 1, everything is done. I'm starting from n. And yeah, I think this should work. I don't know. What? Okay, yeah, another base case, I think, if j equals to 0 but I equals to, yeah, for j, even for j equals to 0, if I is anything 1 or n, then also dp of I of 0 is going to be int max, right? So for j equals to 0, I think everything is done. So I think, yeah, because if even if you are left with something like you are at index 1 or you are at index 0, then but you don't have any more partitions, so for that also I do this thing in max, right? And yeah, I think now at least this should be working. Output is 1, which is alright. It's 2 and it should be 0, and it's doing alright. So let me try to. No, it got accepted. So yeah, that's partition db plus. Wait, what? I've already done this. Anyway, I don't know what this is. I've already seen the solution. Okay, what do I need to find? Maximum spanning tree stability with upgrades. Okay. Right. You are given an integer n representing an n nodes. Okay, so what is my rank? Yeah, 1430 is good. I'll also do this and then the best rank ever. Okay, you are given an integer n representing n nodes numbered from 0 to n minus 1. Okay, and a list of edges where edges of I equals to e of I, v of I, s of I, must of I. Oh my god, so many different values we have for edges and n nodes. Given by representing a node between edges, and s is the strength of the edge, must I. Okay, I think this was a POTD question, I remember. This was a POTD question long time ago when I was like in end of first year, I think, as far as I remember. And at that time I think I was new to solving graph questions. Yeah, remember this question. Like it was actually a hard question. I don't know how I solved it. I didn't actually look any solutions, but I still solved it. Anyway, you're also given an integer k, the maximum number of upgrades you can perform. Each upgrade doubles the strength of an edge, and each eligible edge can be upgraded at most once. Okay, the edge must be included in the spanning tree. These edges cannot be upgraded. Okay, so must I means the edge must be included in the spanning tree. Okay, and these edges cannot be upgraded. Okay, so I can do some upgradation, right? Si is the strength of the edge. Okay, you are also given an integer k, the maximum number of upgrades you can perform. Each upgrade doubles the strength of an edge. Okay, right, and each eligible edge can be upgraded at most once. So if I have must of 0, so I can only upgrade it once, right? Not more than that, only upgrade once. And for must equals to I, so wait, those we cannot upgrade which has must equals to 1, but this edge will be included in the spanning tree. These edges cannot be upgraded, but this edge must be included in the spanning tree. Okay, but if you are also given an integer k, the maximum number of upgrades you can perform. Okay, can't believe I solved this question. When did I solve this? Each upgrade doubles the strength of an edge, and each eligible edge can be upgraded at most once. Okay. Alright. Stability of a spanning tree is defined as the maximum strength score among all edges included in it. Okay. Written the maximum possible stability for any valid spanning tree. If it is impossible to connect all nodes, return -1. Interesting. So yeah, okay, so first of all what we need to do here is make a graph. Before I make a graph, I should think about this problem a little bit, like what exactly do I need to do. Like I'll have to change the edges such that it is always a, so like for example, if I can double the strength of an edge, so at most once, right? So I'll always, this is okay. I'm just going to solve it, okay guys. The solution, let me tell you because I don't have time, that's why I'm trying to do it. So basically my idea is, whenever I get an edge, I try to make sure it is in the spanning tree, but if it cannot be in the spanning tree, if it is making a cycle, right? Okay, so at first I'll try to build the spanning tree. Okay, how do I build the spanning tree? So I have these edges and I'll connect UV, then I'll connect these things. So basically whenever I encounter some must is zero, right, which means, and the edge weight is maximum, then I'll always double this thing. I'll always double this to, when I double this instead of some other thing, then other must zero will always have lesser value than this. If I double that and not double this one, then I don't think it will be of any use. But at the same time also I need to be so at first I'll try to get all the edges as possible, get all those edges which have ones, and then do the things, and like build the tree, and then what is left, like those are zero which are left, right? So 0, then I'll just do this. Whenever it's making a cycle, I'll just do this. So I can break it into two parts. So let me sort edges dot begin, edges dot end. Vector A, and we have this vector B. And what I'll do, if A of 3 is 3, return true. Else, if this is not true, if this is not, if 3 is not bigger, they are equal, right? Then I'll sort it in terms of the edge weights. So if a of 2 is greater than b of 2, then return true. So basically I'll just return this. So when I do this, everything is sorted in terms of, so for all the I, so I equals to 1, I'll make a DSU, because this is DSU is needed, because this is how you literally form the, so vector s pies and DSU int n s dot resize n with 1 and pi dot resize of n to be equals to n, okay, and then parent of I is equals to I, okay. So find int u will be, if pi of u equals to u, then return u, else return pi of u equals to find of pi of u, right?